The second step of this exercise is actually going to focus on subtracting pointers from pointers, subtracting values, integer values from pointers. So we are going to illustrate once again what has been explained in the textbook. So the first part of this exercise consists in having you add to the previously developed code the series of printf statements. So we are going to get in the code directly and where I inserted them already and see what they are all about. We are displaying here as part of our step 2 a first address, which is myArrayIndex1. So there is a %p here and there is a myArrayIndex1 address value here. Second address will be the address of myArrayIndex0. Then we do the difference, myArrayIndex1 minus myArrayIndex0. So the address of the second element of the array minus the address of the first element of the array. Let's save this code. We are going to compile it and test it first, and then try to deduce something from what we observe. Let me go back to the GCC command here. Let's run it. So this is a code for step 1. Okay, we already covered that. Code for step 2. My first address is 0x, which means it's an hexadecimal number, and then here is my number. Finish is in B4. My second address, finish, is in B0. So even if you are not too fluent with hexadecimal, from B0 to B4 goes 4, right? So if we talk about memory addresses in the RAM, each byte is addressable, and there are 4 bytes between this address, second address, and the first address. That means that this is where the first element of the array starts, and the second element of the array starts 4 bytes later, which makes sense. We have an array of integer. Each integer is coded over 4 bytes. Now, when we compute the difference, however, the value that we get is not 4, but 1. So this is exactly what this exercise is trying to point you to. What is the value you expected? Well, if you are following the logic that every byte is addressable in memory, etc., you come to the conclusion that the difference between the two addresses should be 4. However, when you ask C to display this difference, it displays 1. So why is that different from what we expected? And what do those difference of address represent? Well, the address themselves represent bytes. Okay, there are 4 bytes between the two element of the array, so there is a difference of 4. However, when you compute the difference of 2 pointers in C, you do not get a result expressed in a byte unit. You do not get a result expressed in kilobytes ever. What you get is a result expressed in in units corresponding to the size of the type of element stored in our array. So we store integers in our array. The size of an integer is 4 bytes. Therefore, when the difference between the two addresses is 4, it's converted immediately into 1, which is 1 time the size of an integer. So this is the first remark here that I wanted you to link to the content of the textbook. Second thing we are going to do, well, okay, we understand now what the difference between 2 pointers leads to in the C language. Let's try to add some code to our little program so that this time we have a pointer named P to which we assign the address of the element myArrayIndex2, and we then display on the screen the value of those expressions. So let's go back to our program. So here's the code modified to include those little modification here. In star p declared, p is assigned address of element myArrayIndex2, and then we have simply the free printf that were mentioned in the exercise as %p. Printf of p content of the variable p minus 1, so the address of element myArrayIndex2 minus 1, then minus 2, then minus 3. Make sure this code is saved. Jump to the Conqueror window. Let's compile it again. Execute it. Okay, this is what we get. So now what we need to do in the exercise is, if I can go back to the original screen, there we go, try to figure out how those addresses relate to the element of my array. So that should be relatively easy to do. Go back to Conqueror. This is the address of element index 0, 1, and 2. And you will observe that every time we run the program, those addresses are changing. So P minus 1, P is the address of element index 2. I should have maybe displayed its original address there. P minus 1 is, well, the address of element index 1. So the minus 1 here, and this will be the next question, is not meaning 1 byte, 1 kilobyte, 1 megabyte, 1 gigabyte, whatever you can think of as far as memory unit goes. But it corresponds to 1 time the size of an integer. That is what the array contains. So P minus 1 is 1 element before element index 2. P minus 2 is 2 element before element index 2, which is this element here. And P minus 3 puts us 1 integer worth before actually the beginning of our array. And I have to stop clicking when I'm trying to highlight code, otherwise that triggers cut and paste, which is what you are seeing right now, kind of freezing Conqueror. Okay, so back to the exercise. How do those value relate to each element of my array? Well, we saw that already. P points to element index 2, P minus 1 element index 1, P minus 2 element index 0, and then the other one is of one size of an int before the array. And are these the same as subtracting 1 from the exact decimal value contained in P? No, not at all. Why so? Because every time you subtract with pointers in C, you are talking about units that are size of the element contained in your array. So subtracting 2 pointers tells you how many elements are between those 2 addresses inside an array. Trying to subtract 2 pointers outside of the context of having those 2 pointers point to different elements of an array doesn't make sense. So don't even try to do that. Subtracting integer value from pointers boils down to moving inside of an array. So once again, pointer arithmetic really only makes sense when you are in the context of an array and you have a pointer on one or several elements of that array. So by adding 1, subtracting 1, etc., to a pointer on the element of the array, you make it point to the next or the previous element in that array, which we are going to use actually quite a lot to facilitate sometime iteration over arrays. So I'm going to put back the code here, and we are done with this step of exercise A02.